Here we have this problem, x squared plus 3x plus 3x plus 9. And we're going to factorize these by using the HCF and, if possible, the grouping. So what I'm going to do, I'm going to work with these two together first, right? And I'm going to identify the highest common factor, which is just x. That means x can go into x squared and x can also go into 3x. Alright, so I'm going to factor out that x, and then I'm just going to divide all these terms by x. So x into x squared goes x times, so open bracket, x. And then x into 3x, these will cancel. So I'm left back with a positive 3. So I just factorized the first part. So we're not done yet because we have the second part to do. So I'm just going to put a bracket with these two. And I'm going to factor out a positive 3. So because positive 3 can go into 3x. And a positive 3 can also go into 9x. Or just 9, my bad. So I'm going to factor out that plus 3. That means I'm going to divide both of these by 3. So 3x divided by 3 will just give us x. So x comes here. And 9 divided by 3 goes 3 times. So this is a positive 3. If you look at the brackets, right? This bracket, x plus 3. And this bracket, x plus 3. That means we can go ahead and factorize by the brackets because the brackets are common. So I'm going to have x plus 3. And then I'm going to open up a new bracket now. And I'm going to divide both of these terms by the bracket x plus 3. So I'm just dividing by what is common. So this will cancel this, leaving us with just x. And this will cancel this, leaving us with just plus 3. If you look at these brackets, x plus 3 and x plus 3, you notice that they're exactly the same. So we can simplify this by saying x plus 3 all squared. This is what we call a perfect square because we're multiplying two brackets that are exactly the same. So here we have x squared minus 4x plus 4x minus 16. And we're going to try to factorize these. So I'm going to group the first two, x squared and that minus 4x, and identify the highest common factor. I know that x can go into x squared and x can also go into minus 4x. So we're going to have x on the outside. And then I'm going to divide everybody on the inside here by that x, that common factor. So x squared divided by x just going to give me x by itself there. And then negative 4x divided by x, these cancel, leaving me with just minus 4. Great. So we have completed the first bracket. Now we need to look at the second part. That 4x and that minus 16. So I know that 4 can go into 4x, and I also know that 4 can go into minus 16. So I'm going to factor out a positive 4 and open up a new set of brackets. This means I'm going to divide everybody up here by that 4, that highest common factor. Good. So 4x divided by 4, these cancel, leaving me with just x right here. And then I have minus 16 divided by 4. That is going to give me a negative 4. Good. Because 4 into 4, 1, and 4 into 16, 4 times, and there's that negative. Now, just like the last time, if you look at the brackets, you have x minus 4 and x minus 4 again. That means we can factor out x minus 4 from both sides. So if I do that, I'm going to put x minus 4 out here, which is the common factor. I'm going to open up a new set of brackets now. What will go inside of those brackets is what is left after we divide both terms by the bracket. So I'm dividing this by x minus 4, and I'm dividing this by x minus 4 as well. So notice the bracket at the top here cancels the bracket at the bottom here, leaving us with just x. The bracket at the top cancels the bracket at the bottom because they have the same exact things, leaving us with just a positive 4. Now, let's look at what is left. We have x minus 4 and x plus 4. Notice that they're the exact same thing. The only difference is the sign that is right here. One bracket has a minus 4 and the other bracket has a plus 4. To get the final answer, you just leave it like that. This is what is known as a difference of two squares. Notice the difference between the two brackets is that one is negative, one has a negative in there, and the other one has a positive. Difference.